Hello there and welcome to the Sleepy Universe story. I'm so glad you've joined me tonight. Tonight's journey takes us into the quiet company of moons. These wandering companions drift around planets, large and small, shaping tides, stirring atmospheres, and hiding secrets deep beneath their surfaces. Some are scarred and ancient, silent witnesses to billions of years of cosmic history. Others are restless, alive with volcanoes, geysers, and shifting ice. Our own moon is just the beginning. Farther out you'll find Titan with its seas of liquid methane, Europa with its hidden ocean, Enceladus spraying shimmering fountains into space. Moons can be potato-shaped, sponge-like, or glowing with roars of their own. Some may even cradle the chemistry of life. To know the moons is to glimpse the hidden stories of the solar system. If you enjoy these gentle journeys, consider liking and subscribing or share some thoughts down in the comments. It helps others find their way here. One sleepy soul at a time. But for now, you don't need to do anything at all. Just settle in, let your breathing slow, and let the key-at rhythm of these moons carry you. If you're ready, let's begin. Earth's moon is slowly escaping our planet's gravity. Every year, our moon drifts about 1.5 inches farther away from Earth. It happens because Earth's rotation stirs the oceans into tides, and those tides transfer energy to the moon, nudging it upward. This means that long ago, the moon hung closer in the sky, much larger, much brighter, and more powerful in its pull. It also means that in the distant future, Earth's days will grow longer as the planet's spin slows down. Though the process is incredibly gradual, it's a reminder that even something as steady as the moon's orbit is quietly changing with time. The sky we see tonight is not the same sky our distant ancestors saw, and it won't be the same our descendants inherit. The moon once had an atmosphere of its own. Billions of years ago, the moon was not the silent, airless world we know today. Volcanoes once erupted across its surface, releasing plumes of gas, so much that the moon briefly held a thin but real atmosphere. This atmosphere was thick enough to linger for tens of millions of years, but too fragile to survive forever. The gases gradually escaped into space, leaving the moon bare and exposed. Scientists believe this ancient atmosphere might have helped water molecules find their way into shadowed craters, where they remain frozen even now. When you look at the moon, it's easy to imagine it as eternal and unchanging, yet its past tells a different story, a time when it breathed, however briefly, before falling silent again. Some moons are shaped like potatoes or flying saucers. Not all moons are perfect spheres. In fact, many small ones have strange, irregular shapes. Mars' moon Phobos looks like a lumpy pota. Saturn's tiny moon Pan resembles a ravioli or flying saucer with a raised ridge around its equator caused by material swept from Saturn's rings. These odd shapes form because smaller moons don't have enough gravity to pull themselves into a sphere. Instead, they remain jagged, bumpy, or disc-like, reminders of their chaotic origins. Some were born from debris, others captured from wandering asteroids. Their silhouettes are quirky, almost playful, like cosmic toys scattered across space. While giant moons look like worlds, these little ones feel like fragments, leftovers from the great construction of planets and solar systems. Europa's hidden ocean may contain more water than Earth. Beneath Europa's cracked icy crust lies something extraordinary, a global ocean. Evidence suggests it could contain more than twice as much water as all of Earth's oceans combined. This ocean remains liquid not because of sunlight, but because Jupiter's gravity constantly stretches and flexes Europa, generating internal heat. The surface is striped with lines and ridges, hints of shifting ice above the hidden sea. Some scientists imagine hydrothermal vents on its ocean floor are places where warmth and minerals could mix to create the chemistry of life. Though Europa looks barren on the surface, it may be one of the most promising places in the solar system to find living organisms beyond Earth in its silence. On its surface, but instead of water, Titan's rivers, lakes, and seas are filled with liquid methane and ethane. Clouds drift above and rain falls, shaping landscapes that eerily resemble Earth's. But in alien chemistry, imagine standing there, the sky orange and hazy, the air thick with nitrogen, the horizon lined with shimmering hydrocarbons. Say, as Titan's strange cycle of rain and rivers may even hint at organic chemistry similar to what sparked life here on Earth, it is both familiar and alien. A frozen world with weather seasons, and the landscapes sculpted by a liquid utterly unlike our own. Enceladus erupts geysers that shoot into space. Tiny Enceladus, another of Saturn's moons, has become one of the most fascinating worlds in the solar system. Beneath its icy crust lies a salty ocean, and from cracks near its south pole, geysers erupt. These fountains spray water vapor, ice crystals, and organic molecules hundreds of miles into space, creating a dazzling plume visible even from orbit. The geysers are so powerful, they help feed Saturn's rings. More astonishingly, the material they contain suggests conditions that could support microbial life. Cassini, the spacecraft that studied Saturn, flew directly through these plumes, tasting their chemistry. In those shimmering jets, we glimpse the possibility of an ocean world alive with hidden energy. A tiny moon that constantly announces its presence with spectacular glittering sprays. Io's explosive volcanoes outshine anything on Earth. Io, the inert host of Jupiter's large moons, is a world of fire. Its surface is scarred with hundreds of active volcanoes, some so large they shoot molten fountains miles high. These eruptions outshine even Earth's most powerful volcanoes, fueled by the immense tidal forces of Jupiter and its neighboring moons. The entire crust of Io is restless, reshaped again and again by flowing lava. No two views of its surface are ever quite the same. Standing there would be impossible. The air is thin, the radiation deadly, the ground seething and shifting. Yet from afar, Io dazzles, glowing with the fiery energy of a world forever in upheaval, a living furnace in orbit around a gas giant. Ganymede, the largest moon, has its own magnetic field. Ganymede is not only the largest bone in the solar system, but also unique. It has a magnetic field of its own. Even Mercury, a planet, cannot claim this distinction. This field suggests a molten metallic core hidden deep inside. Surrounding Ganymede is a thin atmosphere of oxygen and a frozen surface scarred by both craters and mysterious grooves. It is so large that if it orbited the Sun directly, astronomers might be called it a planet. Yet, Ganymede is still a moon circling Jupiter, carrying secrets of geology and magnetism that blur the line between moon and world. When we look at it, we are reminded that moons are not mere companions. They can be as complex and active as planets themselves. Without the moon, life on Earth might never have evolved. Earth's moon does more than light the night sky. Its steady pole stabilizes our planet's tilt, keeping our seasons regular. Without the moon, Earth's axis might wobble chaotically, swinging from extreme tilts that would cause ice ages and burn-in summers. Such instability could have made life, as we know it, impossible. The moon also stirs our oceans, creating tides that may have nurtured the chemistry of the first living organisms. In this sense, the moon is not just a companion, but a guardian, shaping Earth into a stable, life-friendly home. Looking at it now glowing softly above us, it's humbling to think that its presence may have been essential to our own existence. Our moon was born from a catastrophic planetary collision. The leading theory of the moon's origin is as dramatic as it is violent. About 4.5 billion years ago, a Mars-sized body, nicknamed Theia, collided with the young Earth. The impact blasted molten rock and debris into orbit, where it gradually coalesced into the moon. Traces of this cataclysm live on Earth and the moon. share strikingly similar chemistry, as if born of the same material. The event reshaped Earth too, possibly tilting its axis and setting the stage or the seasons. What looks like a calm, timeless presence in the sky is actually the product of fire and chaos, a scar of Earth's early history turned into its most faithful companion. The far side of the moon is nothing like the side we see. From Earth, we always see the same face of the moon, the near side, but the far side is strikingly different. While the near side is marked by broad, dark plains called Maria, the far side is covered in rugged highlands and craters. Scientists believe this contrast is due to uneven heating in the moon's early history, which caused lava flow to fill basins only on the near side. For most of history, humans never saw the far side at all until spacecraft revealed its mystery in the 20th century. Looking at those images for the first time was like discovering a second moon, hidden in plain sight, silently turning just out of view. Triton orbits Neptune backwards and may be captured. Most moons circle their planets in the same direction that the planet spins. Triton, Neptune's largest moon, does the opposite. It orbits backwards, a motion called retrograde. This strange path suggests Triton did not form around Neptune, but was likely captured from elsewhere, perhaps once a dwarf planet in the Kuiper Belt. Triton's capture would have been a violent event, destabilizing Neptune's original moons and scattering them. Today, Triton remains an oddball, icy with geysers that spout nitrogen gas into the thin atmosphere and a surface so smooth it looks freshly paved. One day its backward orbit made you in it as Neptune's gravity slowly drags it inward. Eventually, it may break apart into a magnificent ring. Some moons could one day break apart into rings. Moons that orbit too close to their planets live a precarious existence that permits gravity, stretches and pulls on them. And if they cross a critical distance called the rash limit, the moon can be torn apart entirely. Scientists think this fate may await Mars' moon Phobos, which is slowly spiraling inward. In the far future, Phobos could shatter into rubble, forming a ring around Mars. It's a reminder that moons and rings are connected. One can transform into the other. In the early solar system, some rings may have coalesced into moons while others tore moons apart. These cosmic cycles show how dynamic and fragile orbits really are, even though they seem timeless to us. Charon is so big Pluto and its spins are on each other. Pluto's largest moon, Charon, is so large relative to its planet that the two bodies are sometimes called a double dwarf planet system. Unlike Earth and the Moon, where the smaller body clearly circles the larger, Pluto and Charon both orbit around a shared point in space called the barycenter that lies outside of Pluto itself. Charon is about half Pluto's size, and its surface is scarred with enormous canyons and cliffs. This unusual partnership blurs the line between moon and planet, showing that in some cases, gravity binds worlds into equal dances rather than one-sided orbits. If you picture them in motion, it's less like a planet with a moon and more like two companions forever turning together in the dark. Miranda looks like it was shattered and reassembled. Miranda, one of Uranus' moons, looks like a patchwork of broken pieces stitched back together. Its surface is fractured into cliffs, valleys, and ridges, some towering taller than Earth's Grand Canyon. Scientists think Miranda may have shattered in a massive collision long ago, only to reassemble under its own gravity. This explains its strange mismatched terrain where one region looks entirely different from another. The most striking feature is Verona Rupes, a cliff up to 12 meters high, the tallest known in the solar system. Falling from its edge would take 10 minutes to reach the bottom. Miranda feels like a world that survived cosmic trauma, a scarred survivor orbiting Euclid in Uranus' tilted realm. Mars' moon Phobos is spiraling toward its doom. Phobos, a larger of Mars to small moons, is doomed. With every orbit, it creeps about 7 feet closer to the planet. In around 50 million years, Mars' gravity will either tear it apart into a ring or pull it down to crash against the planet's surface. Today, Phobos is covered in grooves and deep cracks that may already be signs of this stress. The moon is small, only about 14 miles across, but its fate looms large. To imagine the Martian sky without Phobos is to realize that moons are temporary companions, their orbits fragile, their futures uncertain. The moon still trembles with mysterious moonquakes. Though the moon seems silent and still, it occasionally trembles. Seismometers left by Apollo astronauts reveal moonquakes. Some are caused by tidal stresses from Earth's gravity. Others are triggered when the cold lunar crust suddenly warms with sunlight, cracking under the temperature shift. And some deeper and stranger come from within the moon itself. Their origins are still not fully understood. These quakes can last far longer than earthquakes because the moon's crust is dry and rigid, allowing vibrations to echo. Though the moon has no plate tectonics like Earth, its interior is not entirely quiet. Each quake is a reminder that beneath its calm surface, the moon remains alive with hidden energy. Tiny glass beads on the moon hide trapped water. Scattered across the moon's soil are countless tiny glass beads formed long ago in fiery volcanic eruptions. Recently, scientists discovered these beads contain water locked within them. Though the moon looks parched and bone dry, these microscopic spheres may store vast amounts of hidden moisture. In the future, such beads could even be harvested to provide drinking water or rocket fuel for explorers. The discovery changed how we see the moon. Not just a barren desert, but a place with resources quietly waiting in its dust. In each small bead lies a trace of the moon's fiery past, and perhaps a key to its future as a stepping stone for human travel beyond Earth. The moon's covered in dust that smells like burnt gunpowder. When Apollo astronauts returned to their lunar modules after walking on the moon, they noticed something odd. The fine gray dust clung to their suits and boots, and inside the cabin, it gave off a distinct smell like burnt gunpowder. Lunar dust, or regolith, is made of tiny jagged shards of rock and glass, ground down by billions of years of impacts. It is so sharp it wore holes in spacesuit fabric and clogged equipment. Though it resembles soil, it is harsher, alien, and dangerous to breathe. To the astronauts, that first whiff was both strange and unforgettable. The scent of a world that has no air, no rain, no life, yet leaves its mark in the sharpest of ways. Astronauts left experiments that are still running today. During the Apollo missions, astronauts placed scientific instruments on the moon, many of which continued operating for decades. One experiment, a set of mirrors called retroreflectors, is still used today. Scientists aim lasers at them from Earth, measuring the time it takes for the light to return. These measurements reveal the exact distance to the sun, confirming that it is drifting away. Other experiments studied the moon's interior and environment, providing insights long after the astronauts left. Even now, the quiet moon carries reminders of those brief visits, silent instruments, gathering knowledge in the darkness, linking Earth and moon with beams of light. Callisto may hold an ancient ocean beneath its crust. Callisto, Jupiter, as second largest moon, is scarred with more craters than almost any world in the solar system. At first glance, it seems geologically dead, frozen in time, but measurements suggest something surprising beneath its icy shell. Callisto may hide a salty ocean preserved for billions of years. If true, this makes Callisto a place where liquid water has endured quietly while the surface above remained unchanged. Unlike Europa's restless ice or Io's volcanic chaos, Callisto is ancient and still. Its hidden sea, sealed beneath layers of ice, might be as old as the solar system itself. In its silence, he could hold secrets of stability, survival, and the long endurance of water in the cold outer reaches of space. Apophis has a mysterious dark hemisphere, Saturn's moon Otis looks like a yin-yang, painted across the sky. One side gleams bright as fresh snow, while the other is stained as dark as coal. This striking two-tone world puzzled astronomers for centuries. The leading explanation: that dark dust from another moon, Phoebe, coats one hemisphere as Enceladus sweeps through space. Once warmed by sunlight, the darkened areas grow dark, still, causing the sharp contrast we see today. Enceladus is also shaped oddly, with a great equatorial ridge that makes it resemble a walnut. Few moons look so bizarrely divided, half glowing, half shadowed, a cosmic symbol orbiting quietly in Saturn's domain. Hyperion spins through space like a tumbling sponge. Hyperion, another of Saturn's moons, is one of the strangest objects in the solar system. It is small, irregular, and full of deep craters that make it look like a sponge. But even stranger is the way it spins. Instead of turning steadily, Hyperion tumbles unpredictably, as if forever losing its balance. No two observations of its rotation match exactly. It's chaotic. Its low density suggests it is porous, like a pile of rubble, barely held together by gravity. This makes Hyperion both fragile and fascinating, a cosmic sponge adrift in Saturn's orbit, forever tumbling in unpredictable ways. Some moons glow with auroras of their own. Auroras aren't limited to planets. Some moons, bathed in the planet's magnetic fields, glow with shimmering curtains of light. Ganymede, with its own magnetic field, shows auroras dancing across its poles. Even moons without fields can sparkle, their atmospheres or surfaces lit up by the charged particles racing through space. These auroras may not be visible to human eyes directly, but spacecraft instruments capture their glow. The thought of a moon silent and airless, crowned with light from an invisible storm, is deeply haunting, a reminder that space is alive with you. Seen energy, painting even the smallest worlds with color. Some moons hide subsurface oceans warmed by tides. Moons far from the sun should be frozen solid, yet many harbor oceans beneath their crusts. The secret is tidal heating. As a moon is stretched and squeezed by its permitted gravity, friction inside generates heat. This warmth can keep water liquid even under miles of ice. Europa, Enceladus, and possibly Callisto or Titan all may have hidden oceans kept alive by this process. These underground seas are some of the most promising places to search for extraterrestrial life. Beneath barren surfaces, entire oceans may be stirring, warmed by nothing more than gravity's steady pull. A few moons have atmospheres thicker than Earth's. It might sound impossible, but Saturn's moon Titan has an atmosphere denser than Earth's. Its sky is filled with nitrogen and a haze of organic molecules. Standing on its surface, the air would press down more heavily than the air does here. This thick atmosphere allows weather, clouds, winds, and rain to shape the land. While Earth's moon has nothing but a trace of exosphere, Titan's skies resemble a young Earth's, offering a glimpse of what our world may once have been like. It's a reminder that moons are not just small companions, but can have environments as rich and complex as planets themselves. Saturn's tiny moon Pan looks like a cosmic ravioli. Pan, one of Saturn's smallest moons, is shaped so strangely, it hardly looks real. With a bulging equatorial ridge, it resembles a flying saucer or a piece of ravioli drifting through space. Pan's odd form comes from the way it sweeps through Saturn's rings, collecting material that builds up around its middle. Barely 20 meters across, it looks like something sculpted by hand rather than formed by nature. But Pan is no toy. It helps carve a gap in Saturn's rings, proving that even the tiniest moons can shape their surroundings in remarkable ways. Mimas looks strikingly like the Death Star. Mimas, another of Saturn's moons, became famous for its uncanny resemblance to the Death Star from Star Wars. Its giant crater, Herschel, dominates one hemisphere, giving it the same eerie look as the fictional battle station. But Mimir is far from menacing. It's a frozen, battered world only about 250 miles across. Its resemblance is pure coincidence. Yet, it has captured the imagination of everyone who has seen its picture. Scientists, however, find Mimers interesting for another reason. Its interior may not be solid. Recent studies suggest it could hide a liquid ocean beneath its icy crust, turning a familiar-looking moon into a much deeper mystery. Amala has valleys taller than Mount Everest. Jupiter's moon, Amla, is small and irregular, but its landscape is extreme. Towering mountains and valleys scar its surface, some rising higher than Earth's Mount Everest. Amla glows faintly red, possibly coated by sulfur from Io's eruptions. Though only about 100 meters long, it plays a role in feeding Jupiter's faint gossamer rings with dust. Its dramatic terrain shows how even the smallest moons can carry features as grand as planets compressed into miniature worlds. Anthem may be tiny, but its peaks and valleys rival the greatest landscapes of Earth. Himalaya is one of Jupiter's strangest captured moons. Far from Jupiter's main moons, Himalaya drifts as the largest member of a group of irregular satellites. It doesn't orbit neatly in line with the others, but instead follows a tilted eccentric path. Scientists believe Himalaya is a captured asteroid, wander pulled in by Jupiter's immense gravity. It measures about 100 miles across and has a dull gray surface, lacking the bright ice of the inner moons. Himalaya is proof that Jupiter gathers serene, turning them into moons and reshaping the population of its system. It shows us that moons are not always born where they orbit. Sometimes they are travelers caught and kept forever. Some moons orbit backwards compared to their planets. While most moons orbit in the same direction their planets spin a few rebel, these retrograde moons circle the opposite way, defying the usual order. Neptune's giant moon Triton is the most famous, but many smaller captured moons also follow backward paths. Their orbits suggest they didn't form alongside their planets, but were captured later, let in from wandering through space. This capture process can be violent, sometimes shattering other moons or changing the tilt of a planet's system. A backward orbit is not just strange, it's a clue to a turbulent history, a reminder that the solar system is full of chance encounters and dramatic captures that reshaped worlds into the configurations we see today. Janus and Epimetheus swap orbits around Saturn. To tiny moons of Saturn, Janus and Epimetheus perform a delicate celestial dance. They share nearly the same orbit, but instead of colliding, they swap places every few years. When the inner moon catches up with the outer, their gravity exchanges energy, causing one to move outward while the other slips inward. This orbital ballet repeats endlessly, a graceful rhythm choreographed by gravity itself. The arrangement is rare, showing how moons can find stable patterns even in precarious positions. Watching Janus and Epimetheus is like seeing partners trade steps in a dance, forever circling Saturn, never colliding, but always moving in harmony. Some moons spin so slowly they barely rotate at all. Many moons are tidally keeping one face always pointed at their planet. To us, this looks like they never rotate, though technically they do just once per orbit. But some irregular moons spin so slowly that their rotation takes days or weeks, appearing almost frozen. Their sluggish motion is caused by uneven shapes and gravitational tugs that gradually dampen their spin. Imagine standing on such a moon. The stars would crawl across the sky at a pace so slow it might take a week to notice movement. These slow rotations remind us that time unfolds differently depending on where you stand in the solar system. The moon helps keep Earth's axis stable. Earth's axis is tilted at about 23.5, giving us our seasons. Without the moon, that tilt could wobble wildly, swinging between extreme angles. Mars, which lacks a large stabilizing moon, has experienced such chaotic shifts, but Earth's moon, with its steady pull, dampened those variations, keeping our climate relatively stable for billions of years. This stability may have been crucial for life to thrive, giving ecosystems time to adapt and evolve without sudden planetary upheavals. The moon's influence is quiet and constant, invisible in daily life, but it acts as a cosmic anchor, steadying Earth's balance in the vastness of space. The moon makes days on Earth longer over time. Long ago, the Earth spun much faster. A single day may have lasted only 6 hours. But as the moon pulls on Earth's oceans, creating tides, energy slowly transfers from Earth's spin to the moon's orbit. As a result, Earth's rotation gradually slows, making our days longer. Today, we add about 1.7 milliseconds to each century. It's a subtle effect, but over billions of years, it adds up. The length of a day you experience now is not the same as it was for the earliest life forms. The moon, simply by circling Earth, has been stretching time itself, reshaping the rhythm of our world. The moon once glowed with lava seas. Look at the dark patches on the moon's surface. Those broad plains are ancient lava flows frozen in place. Billions of years ago, the moon's crust cracked from massive impacts, and molten rock ed up to the surface, spreading into seas of glowing lava. These Latin for seas gradually cooled into the dark basalt plains we see with the naked eye today. To early observers, they looked like oceans, inspiring myths and legends. But their true story is even more dramatic. The moon once shone with rivers of fire. Its face was remade by molten tides that hardened into the rocks we still see each night. Our moon holds frozen water in shadowed craters. At the lunar poles, some craters lie in permanent shadow. Sunlight never reaches their depths, and temperatures they're plunged to hundreds of degrees below zero. In these cold traps, water ice has accumulated over billions of years, delivered by comets and asteroids. The ice is locked away in darkness, etched since it arrived. For future explorers, these icy reservoirs could provide drinking water, breathable oxygen, or even fuel for rockets. The discovery of lunar ice transformed how we view the moon, not just as a barren rock, but as a world with hidden resources. Waiting quietly in the shadows, the moon reflects just 12% of the sun's light. The moon may look bright in the night sky, but it is surprisingly dark. Its surface reflects only about 12% of the sunlight that hits it, darker than worn asphalt. The illusion of brightness comes from the contrast with the blackness of space. If the moon were placed alongside Earth in space, it would look dull gray compared to our blue and white planet. This low reflectivity, known as albedo, is caused by the moon's dusty basaltic soil. What appears to us as glowing silver is really the faint gleam of a world that shines only dimly, yet enough to light our nights and inspire our imaginations. Lunar soil cups through spacesuit fabric like glass. Lunar dust isn't soft like earthly sand. It is made of tiny sharp-edged grains formed by meteor impacts, shattering rock into glassy fragments, without wind or water to wear them smooth. These grains remain jagged and abrasive. Apollo astronauts found that lunar soil clung to everything, wearing down seals, scratching visors, and even cutting through fabric. Breathing it would be dangerous, as its fine particles could lodge in lungs. To walk on the moon is to step into a field of tiny knives, invisible but relentless. Dust is both a record of billions of years of impacts and a challenge for any future missions that return. The moon's gravity makes Earth slightly egg-shaped. The pole of the moon doesn't just raise it east in the oceans, it also stretches Earth itself. The planet bulges slightly in the direction of the moon, making Earth subtly egg-shaped. The effect is tiny, invisible without precise instruments, but it's a reminder of how deeply the moon influences our world. Its gravity reaches through rock, water, and air, tugging gently but persistently. Our planet and its moon are locked in a gravitational embrace, shaping one another in ways we rarely notice, but that ripple across the entire Earth system. Moons can be torn apart by planetary gravity. A moon that strays too close to its planet can cross a point called the Roche limit. Within this distance, the planet's gravity pulls harder on the moon's near side than its far side, stretching it apart. If the tidal forces are stronger than the moon's own gravity, the moon can shatter completely. Astronomers think Saturn's spectacular rings may have formed this way from a moon that wandered too near and was it into pieces. In the far future, Mars' moon Phobos may meet this fate, slowly torn into rubble. The idea that a solid world can unravel into countless fragments shows how fragile and moons are under the immense grip of their planets. Some moons are tidally locked in perfect rhythm. Many moons always show the same face to their planet, a state called tidal locking. Our own moon is the classic example. It rotates once on its axis in exactly the same time it takes to orbit Earth, which is why we always see the same side. Tidal locking happens as gravity gradually slows a moon's rotation until it matches its orbit. The result is a kind of gravitational rhythm, a balance that feels almost like a dance. While it means one hemisphere is forever hidden from its planet, it also creates stability across the solar system. Moons locked in this eternal turn show how gravity shapes time and motion into harmony. Moons sometimes trade orbits with each other. Not all orbits are fixed forever. Some pairs of moons can swap places in a delicate gravitational exchange. Saturn's Janus and Epimetheus are the best known examples, circling the planet in nearly the same path. Every few years, the inner one catches up to the outer, and instead of colliding, their gravity makes them trade orbits. This cosmic switch has repeated for millions of years, a flawless balancing act. It shows how even tiny moons can cooperate in surprising ways, finding stability through motion. Watching them trade places is like seeing gravity write choreography across the heavens. Earth's move and helps trigger earthquakes and volcanic shifts. The moon's pull doesn't just raise tides in the oceans, it also tugs on Earth's crust. The stress from these tides can sometimes trigger earthquakes or influence volcanic eruptions, especially in places already on the edge of activity. Scientists call these tidal stresses, and while they don't cause quakes outright, they can nudge fault lines or magma chambers at just the right moment. It's astonishing to think that the moon, so far away, can have a hand in Earth's rumblings. Our planet and its satellite are connected, not only through light and tides, but even through the shaking of the ground beneath our feet. Ganymede crust is layered like a cosmic sandwich. Beneath its icy surface, Ganymede may have multiple oceans stacked in layers. Imagine ice, then liquid water, then more ice, then more water, a cosmic sandwich reaching miles deep. This strange structure is possible because pressure inside Ganymede is immense, forcing water and ice into exotic phases. With its molten core creating a magnetic field, Ganymede is far more complex than a typical moon. It has features of a planet in miniature, complete with oceans, magnetism, and diverse geology. If we could slice into it, we would see layer upon layer of water and ice, a frozen architecture unlike anything on Earth. Io's lava flows can stretch for hundreds of miles. Io is the most volcanically active world in the solar system, and its eruptions produce lava flows that can stretch for hundreds of miles. These rivers of molten rock glow red hot, reshaping the moon's surface in a constant cycle of destruction and renewal. Some eruptions create plumes that rise hundreds of miles above the surface, visible even from space. Unlike Earth volcanoes, which are scattered, Eos are everywhere, turning the entire moon into a shifting volcanic landscape. Seen from orbit, its surface glows with the fresh scars of eruptions, an endless reminder of the power of tidal heating. Under Jupiter's pull, Europa's ice surface constantly reshapes itself. Europa's surface is a vast sheet of fractured ice crisscrossed with ridges, cracks, and streaks. Unlike the heavily cratered surfaces of most moons, Europa looks young and active. This is because its ice is constantly shifting, breaking, and refreezing, erasing old scars. Beneath lies a global ocean, and heat from tidal forces keeps the ice in motion above it. Some cracks may even vent ocean material to the surface, leaving reddish stains where salts or organics risk. Yup, Europa's constantly refreshed surface hints at a restless world where the frozen crust is only a thin skin over a living ocean. Callisto's ancient craters may be 4 billion years old. Callisto, Jupiter's outer large moon, is a relic of deep time. Its surface is so heavily cratered that it looks like a frozen record of the solar system's earliest days. Some of its largest impact scars may be nearly 4 billion years old, preserved because Callisto lacks the geological activity that would erase them. Unlike Europa or Io, Callisto is quiet with little to no tectonic movement. It is like a cosmic time capsule showing us what the solar system was like during its violent youth. Looking at Callisto is like looking backward across eons into a chapter of history Earth itself has long sunk. Erased, Titan has mountains taller than the Rockies. Though shrouded in haze, Titan's surface holds mountain ranges that rise higher than Earth's Rocky Mountains. These peaks are made not of but of solid water ice as strong as stone. In Titan's frigid temperatures, tectonic forces and perhaps cryovolcanism lifted them, shaping the rugged terrain. To stand beneath these icy ranges would be surreal, mountains of frozen water, and a dim orange sky towering over methane lakes and seas. Titan's mountains show that even in the outer solar system, landscapes can be as dramatic and imposing as those on Earth, carved from different materials, but no less majestic. Enceladus geysers feed Saturn's rings. The icy moon Enceladus constantly sprays water vapor and ice crystals into space from fissures near its south pole. These geysers are so powerful that they replenish Saturn's earring, forming a halo of material that encircles the planet. Every particle in that delicate ring may have once been part of Enceladus's hidden ocean, blasted into space by tidal forces. This connection between a tiny moon and a vast ring system shows the subtle interplay of bodies in orbit. Enceladus, though only about 300 meters across, leaves its mark on one of the most beautiful features in the solar system. Triton's surface is made of nitrogen ice. Triton, Neptune's largest moon, is covered in nitrogen ice that shapes its pale, frozen surface. Unlike water ice, nitrogen ice is soft and mobile at Triton's frigid temperatures, allowing the landscape to shift and smooth over time. Voyager to revealed geysers venting nitrogen gas, leaving dark streaks across the icy plains. These geysers show that Triton is still active, reshaping itself even at the solar system's edge. Its surface is unusually smooth compared to other moons, suggesting it is constantly renewed by this icy activity. To walk on Triton would be to step across frozen nitrogen fields, a place where the ordinary becomes alien and where even ice behaves in strange and subtle ways. Charon has a canyon 4 times deeper than the Grand Canyon. Pluto's largest moon, Charon, is scarred by a canyon so vast it dwarfs anything on Earth. This great chasm stretches over 1,000 miles across the surface and plunges nearly 4 times deeper than the Grand Canyon. Scientists believe it formed as Charon's icy interior expanded and cracked open the crust. The scale of this feature makes it one of the most dramatic gases in the solar system. Standing at its edge, if such a thing were possible, would reveal walls plunging down into shadow, cliffs so immense they would swallow Earth's greatest landscapes. Charon may be small compared to planets, but its terrain proves that even little worlds carry colossal scars. Miranda's Verona Rupes is the tallest cliff in the solar system. Miranda, a small moon of Uranus, holds one of the most astonishing features in the solar system, Verona Rupes, a cliff estimated to be up to 12 meters high. A fall from its edge would take 10 minutes to reach the bottom. Scientists think the bar was once shattered by a massive collision and then reassembled, leaving behind a surface of jumbled terrain and towering cliffs. Verona Rupes stands as a monument to that violent past. Its dizzying scale is unmatched anywhere else we know. On such a small moon, the sight of a cliff taller than Mount Everest stacked 3 times is almost unthinkable. A geological wonder on a tiny scar. Red world, Neptune's moons were likely captured from elsewhere, unlike Jupiter or Saturn, which grew their moons from disks of gas and dust. Neptune seems to have gathered its companions from the Otzi. Many of Neptune's moons follow odd, tilted, or retrograde orbits, strong signs of capture. Triton itself is thought to have been a dwarf planet before Neptune's gravity pulled it in. These captures would have been violent, destructing or even destroying Neptune's earlier moons. The result is a system that feels assembled from fragments of the outer solar system, a collection of wanderers gathered into Neptune's orbit. Looking at them is like looking at fossils of ancient migration, reminders of how dynamic and chaotic the solar system's past really was. Phobos have grooves that may be caused by falling apart. Mars' larger moon, Phobos, is etched with long grooves and cracks that streak across its surface. For decades, scientists debated their cause. Were they carved by impacts or by rocks roaming across the surface? The leading idea now is more dramatic. The grooves may be signs that Phobos is breaking apart. Mars' gravity pulls relentlessly on the little moon, and over millions of years, those stresses could be tearing it from within. The grooves may be the first fractures of its slow-motion destruction. If so, Phobos is a doomed world already wearing the scars of its eventual fate. Deimos orbits so smoothly it barely rises or sets. Mars' smaller moon Deimos is tiny, irregular, and orbits far from the planet compared to Phobos. Its orbit is so high and so smooth that from the Martian surface, Deimos looks like a faint star drifting lazily across the sky. Unlike Phobos, which races overhead and sets quickly, Deimos rises and sets so slowly that it hardly seems to move. To stand on Mars and watch Deimos is to see a quiet, gentle presence, almost motionless against the backdrop of space. Its stillness contrasts with the drama of its companion Phobos, making the Martian sky a stage for 2 very different moons. Some moons are so dark they reflect almost no light. Not all moons shine brightly and reflect sunlight. Some are as dark as coal, reflecting only a few % of the light that strikes them. Jupiter's irregular moon, Himalaya, and many of Saturn's small outer moons belong to this category. Their dark surfaces suggest they may be captured asteroids covered in carbonic material. These moons hide in the shadows, invisible to the naked eye even if we stood nearby. Their darkness speaks of their origins in the cold, primitive outer solar system where sunlight barely reaches. They are among the dimmest wanderers, worlds that whisper rather than gleam. Others are so bright they glow like fresh snow. On the other end of the scale, a moon so bright they reflect nearly all the sunlight that hits them. Enceladus, covered in fresh ice from its constant geysers, gleams like pure snow. Its albedo or reflectivity is among the highest of any object in the solar system. Seen from space, it shines like a pearl, dazzling against the blackness. This brightness is not just beautiful, it tells us that the surface is continually renewed. Where darker moons show their age in scars and soot, bright ones like Enceladus reveal youth and activity. Their shine is a signal of life within, reshaping their surfaces. Again and again, some moons orbit in clusters like miniature solar systems. On the giant planets, moons don't always orbit alone. Dozens of small, irregular moons form loose groups or clusters, circling together like miniature solar systems. Many of them share tilted or elongated orbits, suggesting they are fragments of a single body that broke apart long ago. Jupiter and Saturn both host such moon families. each a collection of shattered pieces held together by their planet's gravity. Studying these clusters reveals the violence of their past, collisions that broke larger worlds into swarms of smaller ones. Today they drift in quiet company, little fragments forever bound to the giants they circle. Jupiter's 4 Galilean moons changed science forever. When Galileo turned his telescope to Jupiter in 1610, he saw 4 tiny stars moving beside the planet. Night after night, they shifted positions, and he realized they were moons orbiting Jupiter. This discovery shook the foundations of science. It proved that not everything revolved around Earth, giving weight to the idea of a heliocentric solar system. The Galilean moons Io, Europa, Ga, 9, and Callisto became the first worlds beyond Earth known to humankind. They remain 4 of the most fascinating bodies in the solar system, each unique, each revealing something new about planetary systems. Their discovery was the first step towards seeing our place in a vast, complex universe. Galileo's discovery of moons proved Earth isn't the center. In 1610, Galileo Galilei peered through his handmade telescope and noticed 4 points of light near Jupiter. Over several nights, he saw them shift, moving around the planet. These were moons Io, Europa, Ganymede, and Callis, 2, and their motion revealed something radical. Not everything in the heavens revolved around Earth. At a time when most still believed in an Earth-centered universe, Galileo's discovery provided undeniable evidence that planets could have their own satellites. It was a turning point in science, shaking ancient assumptions and opening the way to the modern view of the solar system. The sight of those little moons was more than a discovery. It was proof that Earth was not the center of all things. Some moons are locked in resonant orbits. Among Jupiter's Galilean moons, 3 are locked in a perfect gravitational pattern called resonance. Io, Europa, and Ganymede orbit in a 124 rhythm. For every orbit Ganymede makes, Europa circles twice and Rio 4 times. This resonance helps maintain tidal heating inside Rio and Europa, fueling Rio's volcanoes and keeping Europa's ocean liquid. Resonances are not accidents. They are stable patterns gravity carves into systems over time. The dance of these 3 moons is a cosmic metronome ticking with precision across billions of years, keeping their worlds active through the simple rhythm of orbit. Moons can shape their planet's rings with gravity. Saturn's dazzling rings are not just passive structures. They are shaped and sculpted by tiny moons called shepherd moons. These small bodies tug at the ring particles with air gravity, creating gaps, edges, and waves. Pan, for example, clears a sharp groove in Saturn's A ring, while Prometheus and Pandora herd the particles of the F ring into a narrow band. Without these moons, the rings would look very different. The interplay of moon and ring shows how even the smallest bodies can have outsized influence, drawing order and beauty from the chaos of countless icy fragments. Moons are key to understanding how planets form. Moons hold clues to the birth of planets. Some formed from the same disk of material as their parent, others from colossal impacts, and still others were captured long after. Studying their composition and orbits let scientists reconstruct the history of planetary systems. Earth's moon, for instance, reveals the violence of early collisions. Jupiter's moons show the effects of tidal heating. Saturn's moons interact with rings, while captured moons around Neptune and Jupiter hint at ancient migrations. Together, they tell the story of how planets grow, collide, and settle into the systems we see today. Moons are not just companions, they are records of planetary creation. Some moons might hide hydrothermal vents like Earth's oceans. Deep beneath Europa's ice or Enceladus crust, the oceans may hide hydrothermal vents, places where heat and minerals pour from the seafloor. On Earth, each such vents teemed with life, thriving without Sunlight fueled by chemistry alone. If similar events exist on these moons, they could provide energy for alien ecosystems. Jets from Enceladus geysers already suggest salty mineral water rising from its depths. To imagine hydrothermal vents glowing in those hidden oceans is to imagine the possibility of life far from the sun, a parallel biology stirring in the dark beneath alien ice. Life could potentially emerge on moons, not just planets. When we think of habitable worlds, we picture planets, but moons may be just as promising. Europa, Enceladus, Titan, and Ganymede all harbor conditions that could support life. Liquid water, chemical energy, or organic molecules. Unlike barren Mars or Venus, these moons may be alive beneath their surfaces, hidden from view. Life on a moon would expand our idea of where biology belongs, showing that it doesn't need sunlight or Earth-like conditions. It only needs stability. Why water and energy, things moons can provide. They remind us that the search for life is not confined to planets alone. Moons can create their own mini-magnetospheres. While most moons are unprotected, Ganymede stands apart. It is the only moon known to generate its own magnetic field, shielding it with a miniature magnetosphere. This bubble interacts with Jupiter's larger magnetic field, creating auroras that dance across Ganymede's poles. Other moons like Io induce magnetic fields in their parent planet as they move, showing that moons and magnetism are deeply connected. A moon with a magnetic shield would have an advantage in protecting its surface or atmosphere from radiation. These magnetic signatures remind us that moons can behave like tiny planets with complex internal dynamics of their own. Dust clouds from moons can form invisible rings. Some moons are constantly shedding dust, creating faint halos around their planets. Jupiter's small moon Amla, for instance, contributes particles to a tenuous ring around the planet. Even smaller moons and captured asteroids can be surrounded by clouds of debris they've kicked up from impacts. These rings are often invisible to the naked eye, but glow faintly in spacecraft images. They show how moons, even when fragile and eroded, continue to shape their environments. Every impact, every speck of dust leaves as a signature that spreads into space, linking moons and rings in delicate and seen ways. Some moons leak atmospheres into space. Even tiny atmospheres don't last forever. Moons like Io and Enceladus leak gases into space, creating thin clouds that trail behind them. Triton's nitrogen geysers feed a hazy atmosphere that escapes into Neptune's orbit. Titan, despite its like skies, also loses gas to space over time. These leaks contribute to planetary magnetospheres, rings, or tenuous atmospheres. A moon's ability to hold or lose air depends on its gravity and temperature. For many, the pull is too weak and gas escapes endlessly. These leaky moons show us how fragile atmospheres are and how they constantly reshape their parent systems. Moons have been found orbiting dwarf planets beyond Pluto. The Kuiper belt beyond Neptune is filled with icy dwarf planets, and many of them have moons. Pluto has 5, including Con. Jane has 2 and Aes has at least 1. These distant systems are miniature versions of planet-moon relationships, closer in, proving that satellites are common even at the frozen edge of the solar system. Their presence helps scientists measure the masses of their parent bodies and understand how collisions shape these faraway worlds. Each discovery expands the family of known moons, reminding us that the solar system's outer reaches are not empty, but populated with companions orbiting in deep, cold space. Ares and He likely have hidden moons. 2 of the largest dwarf planets in the Kuiper belt, Eris and Ha, are not alone. Eris has a confirmed moon named Denomia, while Hama has 2 known moons, Hiaka and Namaka, but scientists suspect there could be more hidden companions orbiting them, too small or faint to spot with current telescopes. Their very existence suggests that even at the frozen edge of the solar system, collisions and captures gave rise to moon systems. These moons help astronomers calculate the true mass of their parent worlds and shed light on their origins. The fact that tiny distant objects can host their own miniature systems reminds us how common moons really are, companions waiting in the dark. Moons may outnumber planets by the thousands. While our solar system has only 8 major planets, it has well over 200 confirmed moons, and many more likely remain undiscovered. Gas giants like Jupiter and Saturn dominate the count with dozens each, while even small dwarf planets far from the Sun can have companions. Exoplanetary systems, too, may teem with moons, though detecting them is more difficult. The tally could stretch into the thousands across our galaxy. Moons may be the most common type of solid world, quietly outnumbering planets. Their abundance suggests that wherever planets exist, moons are their natural companions, forming or arriving to circle them in great numbers. Some moons orbit so far from their nearly independent worlds. Not all moons cling tightly to their planets. Some orbit at such vast distances that they feel more like captured bodies drifting just within their planet's gravitational reach. For example, some of Jupiter's irregular moons orbit millions of miles away, far beyond the main families of satellites. Their orbits are elongated, tilted, and slow, giving them the feel of almost independent worlds. These distant moons are vulnerable to being nudged away or even stolen by other planets during close encounters. Their tenuous bonds reveal the delicate balance of gravity, where a moon can be both bound and nearly free at the same time. Others skim so close they almost touch their planets. At the opposite extreme, some moons orbit precariously close to their planets. Mars' moon Phobos is so near the surface that it crosses the Martian sky in just a few hours. Jupiter's Io is battered by tidal forces from being locked in a close orbit. Some of Saturn's inner moons practically graze the edges of its rings, moving just above the cloud tops of the gas giant. These moons endure crushing gravitational forces, stretched and pulled by their proximity. Their closeness gives rise to volcanic eruptions, fractured surfaces, or even the slow tearing apart of the moon itself. Saturn's moons sculpt its rings into beautiful patterns. Saturn's ring system is a constantly shifting masterpiece, shaped in part by its many moons. Tiny shepherd moons like Pan, Daphnis, and Prometheus carve sharp edges and gaps, while larger moons exert their gravity to create spiral waves across the rings. The result is a living canvas where delicate ripples and clean divisions trace the invisible influence of orbiting companions. Without these moons, Saturn's rings would be a blurred haze, but together they form intricate and ever-changing patterns. The sight is one of the most beautiful interactions of gravity in the solar system. A cosmic artwork sculpted by moons. Uranus moon and Ns are named after Shakespeare's characters. Unlike most planetary moons, which take their names from myth, Uranus moons are named after literary figures, primarily from the works of Shakespeare. Alexander Pope. Titania, Oberon, Miranda, Ariel, and Umbriel are just a few of Uranus' companions, carrying names from plays like A Midsummer Night's Dream and The Tempest. This tradition makes Uranus unique in the solar system, giving its moons a cultural link to human storytelling rather than ancient mythology. It's as though Uranus carries a library of characters in orbit, reminding us that science and literature intertwine, each shaping how we see the universe. Titan's orange haze may resemble early Earth's atmosphere. Titan, Saturn's largest moon, is shrouded in a thick orange haze made of complex organic molecules. This smoggy veil hides the surface from view, but may mirror the conditions of early Earth, billions of years ago, before life began. Our own atmosphere might have been rich in similar compounds born from the chemistry of sunlight-striking gases. Titan could be a frozen snapshot of Earth's primordial past, showing what a prebiotic atmosphere looks like. Studying it may reveal the chemistry that eventually led to life here and perhaps hint at how life could arise elsewhere. Some moons may harbor prebiotic chemistry beneath icy sheets or within thick atmospheres. Some moons may host the very chemical reactions that precede life. Titan with its methane lakes and organic haze is one candidate. Europa and Enceladus, with salty oceans and hydrothermal possibilities, are others. Prebiotic chemistry refers to the building blocks, amino acids, lipids, sugars assembling into complex molecules. On Earth, is chemistry eventually blossomed into biology. On moons, it may still be happening or may have stalled before crossing that final threshold. These places remind us that life is not inevitable, but its seeds may scatter widely in the cosmos. Moons could serve as refuges for future space colonies. As humanity looks outward, moons may become natural stepping stones. Our own moon is already a candidate for bases with water ice and shadowed craters. Mars moons, Phobos and Deimos, could serve as staging grounds for missions to the planet. Titan with its thick atmosphere offers protection from radiation, while Ganymede's magnetic field provides another kind of shield. Though distant and challenging, these worlds could become havens, supporting human outposts or even long-term colonies. In time, moons may be as important to humanity's expansion as continents were to Earth's explorers. The moon acts as Earth's first shield against impacts. Earth's moon does more than lig the night sky. It acts as a guardian, intercepting or deflecting meteoroids that might otherwise strike Earth. Its scarred surface is a record of countless collisions over billions of years. Why? When not all threats are stopped, the moon's presence reduces the number of impacts Earth receives. It also stabilizes Earth's tilt, preventing extreme climate swings that could challenge life. In a very real sense, the moon has been both shield and stabilizer, helping Earth remain a relatively safe cradle for life. Without it, our planet's history might have been far harsher. The moon once glowed red during ancient eclipses. For as long as humans have watched the skies, lunar eclipses have turned the moon a deep blood red. This striking sight happens, and Earth passes directly between the sun and the moon, casting its shadow across the lunar surface. Instead of vanishing in darkness, the moon glows red because Earth's atmosphere bends and filters sunlight, scattering blue light and letting only the warm tones slip through. Ancient observers saw this as an omen, a fiery transformation of the night's companion. But today we know it's the same process that makes sunsets crimson. During the moon becomes a giant red reflection of every sunrise and sunset happening across Earth at once. Moons can be swallowed when planets migrate. Planetary systems don't always stay where they begin. Giant planets often drift inward or outward over millions of years, tugging moons with them. Some moons survive the journey, while others are lost to space or swallowed by their parent planets. Gravity. Scientists think Neptune's moon Triton was captured during such migrations, while other moons were likely consumed long ago. Migration explains why many distant worlds have irregular satellites with strange orbits. The fates of these moons remind us that cosmic systems are not static. They shift, shuffle, and sometimes sacrifice our satellites to the great reshuffling of planets. Some moons formed from rings that collapsed. Moons don't all form the same way around Saturn. Scientists believe that some smaller moons may have coalesced from its rings. When icy particles within the rings clumped together under gravity, they slowly grew into moonlets. Over time, these gathered enough mass to shape themselves into small moons orbiting at the rings' edge. This process shows how moons can be born from a planet's adornments. Just as Earth's moon likely arose from a colossal impact, Saturn's moons may be the children of its shimmering rings, fragile, glittering nurseries where gravity builds lasting companions. Moons may carry traces of comets that struck them. Moons, with their airless surface, Ease and lack of erosion preserve the scars of every impact across billions of years. Some of those impacts came from comets, icy bodies carrying water and organic molecules. When comets land into moons like Europa or Ganymede, they may have delivered materials crucial to chemistry, perhaps even the seeds of life, unlike Earth, where weather and geology erase ancient evidence. Moons are time capsules. They may still hold the frozen traces of those cometary visitors, preserving a record of cosmic deliveries that once reigned across the solar system. A moon rings like a bell after quakes. When Apollo astronauts placed seismometers on the moon, they discovered something unexpected. After moonquakes caused by tidal stresses or meteorite impacts, the vibrations echoed for hours. The moon rang like a bell, its rigid, dry crust transmitting seismic waves far longer than Earth's dampened rocks. This eerie quality revealed a great deal about the moon's structure, including its fractured outer shell and solid mantle. For scientists, the ringing was a gift, helping them probe the moon's interior. For the rest of us, it adds a ghostly strangeness to Earth's sea companion, a world that hums when struck. Titan has rivers and lakes of liquid methane. Titan is the only world besides Earth known to have stable liquids on its surface, but instead of water, its lakes and rivers are filled with liquid methane and ethane, flowing under a thick hazy sky. Vast seas such as Kraken Mare stretch for hundreds of miles, while branching rivers carve valleys through its icy crust. This alien hydrological cycle mirrors Earth's. Methane evaporates, forms clouds, rains down, and fills lakes again. Titan shows us that other worlds can host familiar processes with entirely different ingredients, rewriting our idea of what a living landscape looks like in the cosmos. Enceladus's south pole is a landscape of tiger stripes. Saturn's moon Enceladus hides an ocean beneath its icy shell, but at the South Pole, the surface is marked by long parallel fissures called tiger stripes. From these, geysers of water and ice burst into space, feeding Saturn's E-ring. With fine particles, the tiger stripes are warm, compared to surrounding ice. Kept active by tidal forces flexing the moon's interior. They provide a direct window into Enceladus's ocean, ejecting salty water and organic compounds into space. For scientists, these stripes are more than geology. They are vents into a hidden ocean that may harbor life. Europa's ocean contains more water than in all Earth's seas. Europa, one of Jupiter's Galilean moons, hides a vast ocean beneath its icy surface. Estimates suggest this ocean contains more than twice the volume of all the water on Earth combined. Trapped under miles of ice, it is warmed by tidal heating from Jupiter's immense gravity. This makes Europa one of the most promising places in the solar system to search for life. Its smooth, fractured surface hints at movement below, and plumes detected by spacecraft suggest water occasionally erupts into space. Europa's hidden ocean is a colossal unseen sea, a whole world of water beneath a frozen crust. Some moons are slowly spiraling into their planets. Not all moons are destined to survive. Mars' moon Phobos, for example, is gradually spiraling inward, pulled closer by tidal forces. In about 50 million years, it will either crash into Mars or break apart into a ring. Other moons face similar fates depending on their size, orbit, and the tidal forces of their planet. These slow death spirals unfold over immense time scales, but they remind us that even moons are not permanent fixtures. Their orbits evolve, and their destinies can include violent ends as they are consumed by the worlds they orbit. Distant moons may be captured objects from the Kuiper Belt. Many of the regular moons orbiting giant planets have strange tilted or even backward orbits. These clues suggest they did not form where they are but were captured. Some may have come from the Kuiper Belt, the distant realm of icy buoys beyond Neptune. Triton, Neptune's largest moon, is thought to be such a capture. once a Kuiper belt object drawn in by Neptune's gravity. Captured moons carry the fingerprints of distant regions, dragged inward from the solar system's icy frontier. They are cosmic migrants, proof of a dynamic system where planets and moons trade bodies across billions of years. Some moons are so small, they're just giant space rocks. Not every moon, a grand spherical world. Many are only a few kilometers across, more like captured asteroids than proper moons. Mars Deimos, for instance, is just a lumpy rock barely 12 kilometers wide. Jupiter and Saturn host dozens of these tiny, irregular satellites, some less than a mile across. They lack the gravity to pull themselves into round shapes, so they remain jagged potato-like bodies tumbling through space. These miniature moons may seem insignificant, but they're cosmic fossils, leftover building blocks from the birth of planets, preserved in orbit, rather than swallowed or shattered. Other moons rival planets in size. At the opposite extreme, some moons are so large they could almost be considered planets themselves. Dainty Jupiter, its biggest moon, is larger than Mercury. Titan, Saturn's largest, has a thicker atmosphere than Earth. Callisto and Io are bigger than our own moon by far. If they orbited the sun directly, astronomers would classify them as planets instead. They circle giant worlds, companions so large they host their own magnetic fields, atmospheres, and geological processes. These moons blur the line between moon and planet, reminding us that labels are often arbitrary in a universe full of diversity. Moons hold the record for the coldest known places in the solar system. The coldest temperatures ever measured in our solar system were not on distant Pluto, but inside craters on Earth's own moon. In permanently shadowed regions near the lunar poles, where sunlight never reaches, spacecraft have recorded temperatures as low as -410 F. These regions are colder than the surface of Pluto or even the outer Kuiper belt. The frigid darkness locks away water ice, preserving it for billions of years. These frozen traps may one day provide fuel and resources for explorers, turning the moon's coldest places into stepping stones for space travel. Some moons glow with reflected light, bright enough to cast shadows. Saturn's moon, Enceladus, covered in bright, fresh ice, reflects almost all the sunlight that hits it. This dazzling reflectivity makes it shine so brilliantly that it can cast shadows in space. Such albedo, the measure of reflectivity, gives Enceladus a ghostly glow against the dark sky. Other moons, too, reflect enough light to create stark brightness around their orbits. These glowing worlds act like cosmic mirrors, scattering sunlight far and wide. Their brilliance is not just aesthetic, it also tells astronomers about the composition of their surface, revealing fresh ice, clean frost, or ancient darkened rock. The moon has no wind, so astronaut footprints remain. When Apollo astronauts stepped onto the moon, their boots pressed into the soft lunar regality, leaving crisp prints. Unlike Earth, the moon has no atmosphere, no wind, and no rain to erase them. With no erosion, those footprints, along with rover tracks, disconnected equipment, and even the American flags, remain preserved. They will likely endure for millions of years, silent markers of humanity's first steps beyond Earth. Each print is a snapshot of a moment in history, frozen in time, a reminder that the moon is both a natural satellite and a lasting archive of human achievement. Some moons are so young they're still forming. Not all moons are ancient. On Saturn, astronomers have spotted small moonlets forming at the edges of its rings. These are newborn moons created as icy particles clumped together under gravity. They may one day grow large, and break free from the rings entirely, becoming stable satellites. This process shows that moon formation is not just a story of the distant past, but an ongoing reality. We may be witnessing in real time the birth of new companions on a giant planet. It's a reminder that our solar system is still alive with creation and change. Moons may shatter and reform after catastrophic collisions. Moons live dangerous lives. Collisions with other bodies can shatter them completely, yet sometimes gravity pulls the fragments back together, reforming the moon in a new shape. Saw turns small moon pan with its ravioli-like appearance may be the result of such a process. Astronomers believe Earth's moon itself was born from a colossal collision that tore apart a Mars-sized body. These violent origins show that moons are not fragile ornaments, but resilient survivors, able to be destroyed and reborn. Each moon carries scars or structures that tell of cosmic violence and the power of gravity to rebuild. The origins of many moons are still unsolved mysteries. While we know some moons formed from impacts, others from capture, and some from coalescing disks, the origin stories of many remain uncertain. Triton's backward orbit suggests capture, but the details are debated. Some irregular moons may have been born in collisions between larger satellites. Even Earth's moon, once thought to have a single clear origin, may have a more complicated history than the classic giant impact theory alone explains. These mysteries keep scientists searching, piecing together evidence from orbits, compositions, and craters. Every moon's story is a puzzle, part of the greater history of how worlds come to be. Exomoons could be even stranger than the ones we know, beyond our solar system. Astronomers are beginning to glimpse possible exomoons, moons orbiting distant exoplanets. Though none are confirmed yet, theories suggest they could be stranger than anything nearby. Some may orbit gas giants close to their stars, basking in warmth. Others might be Earth-sized with thick atmospheres and liquid oceans. Some could even and host life. Because exomoons are so hard to detect, they remain tantalizing mysteries, waiting for better telescopes to confirm them. The first true discovery will be revolutionary proof that moons are not just common, but unimaginably diverse. Across the galaxy, moons remind us that planets rarely travel alone. As we look across the solar system and beyond, a pattern emerges. Planets almost always have companions, from Earth's single moon to Saturn's crowded family, from tiny irregular satellites to giant worlds like Titan. Moons are everywhere. They shape their planets, stabilize their tilts, create tides, feed rings, and sometimes host oceans of their own. They are not afterthoughts, but integral parts of planetary systems. Moons remind us that isolation is rare in the universe. Most planets are not obsolete wanderers, but members of partnerships forever bound in gravitational embrace. And so our quiet journey among the moons comes to a close. We've wandered from Earth's own companion with its silent footprints and glowing eclipses to the icy oceans of Europa, the fiery volcanoes of Io, and the frozen geysers of Enceladus. We've seen moons sharp, like potatoes, moons larger than planets, and moons still being born in Saturn's rings, each one a reminder that the universe is rich with companions, orbiting an endless rhythm. As you doctor if towards sleep, let your thoughts circle gently, like moons around a planet. There is no need to hold on to the details now, only the feeling of vastness, of quiet worlds in orbit of time, stretching across billions of years. The night sky is full of stories, and moons are among its most beautiful whispers. If you've enjoyed this soft voyage through science, consider liking and subscribing, or leaving a gentle thought in the comments. It helps others find their way here too, one sleepy traveler at a time. But for now, let the day settle behind you. Let your breathing fall into its own steady orbit, calm and unhurried. Imagine yourself drifting weightlessly, like a moon bathed in pale starlight, carried endlessly around a gentle, unseen center. Sleep well, dream deep, lie, and may your night be as peaceful as the quietest of moons. Until we meet again in the next video, good night.